So, question I get is, Mitch, we're in vehicle. How on earth do we measure torque and speed on the road? They go, we don't want to spend a ton of money on a custom torque sensor. We don't really trust strain gauging the half shaft. We're looking at competitor vehicles, so it's kind of difficult to tear them apart anyhow. So I hopefully have maybe not some quite so clever answers, but some answers for how that could be approached. So a customer of mine did some really fantastic work validating that they can use vehicle measurements to really successfully benchmark a competitor vehicle. So the way this test started was they had a competitor vehicle, and they brought it on a chassis dyno, and they instrumented the electric powertrain, and then they took the torque and speed measurements from the dyno. So they had the torque and speed measurements here, and what they did was, in my graph, I have speed on the X, torque on the Y, and these values have been distorted, so I don't think they're actually indicative of any particular vehicle. And we can follow the path of the vehicle as it speeds up, as it goes through kind of that torque speed curve. We get into that field weakening region, and this thing is just doing loops, and it's kind of trying to hit every point of that torque speed curve on that chassis dyno. And what they were doing is really looking at the full capability curve of that machine and trying to look at what is this electric machine capable of, what are its regen quantities, all this good stuff. So they mapped out this full kind of boundary condition for the electric machine. And they also calibrated the in-vehicle torque and speed measurements. So they were able to get the can line off of the vehicle, look at what the vehicle can was doing, validate it with this benchmark test, and then they had a really nice base for going out in the vehicle and validating it. So next step, they took the vehicle, they instrumented it, they were reading the CAN bus and then the electrical signals with the eDrive system. There was no chassis dyno, and they ran it on a variety of tracks. So we started out with this chassis dyno information. We got this torque speed envelope of the capability of the machine, and they ran the vehicle on a variety of tracks. So track one, we start off little torque speed, we do a couple loops in here. Eventually we speed up, and we look like we're hitting this top end of that torque speed curve. Then we come down at the higher speed, lower torque, and we can see it really likes operating in this region. Oh, and here's where my pen gets the best of me. I gotta erase this. For the next track, so this is track two, we get a little bit different. We accelerate hard. We try to get that early part of the torque speed curve. We get some of those high ends, and we push it out a little bit further. Third track, we have a lot of operation in this area. But again, we're really filling out where is this vehicle actually operating. And if we look at all those curves, we get a really nice picture of one, where this vehicle likes to live. It likes to live at kind of this 2,000 RPM, 100 Newton meter area. It likes to live at this 6,000 RPM, 50 Newton meter area. But we also can hit a fair amount of those torque speeds. So we can start to understand the control of the vehicle. We can understand where our competitors like to operate their machines. We can actually get quite a bit of good efficiency data out of this. Now the efficiency data I'm not allowed to show, but one cool thing, and I'll show that in my next slide, is how we can monitor the electrical state. So we have these torque and speed values we're pulling off the CAN bus. It's not perfect, but it's pretty good. But what we're really concerned about is the inverter or the electric machine. We have some really cool ways where we can monitor the electrical signals in the vehicle, so that a driver can know what points they're hitting. So I went and I took the liberty of displaying way too many different ways to look at data. So, if you're a driver, you might look at one or two of these things, probably not all of them, or a passenger with a driver. But as you're going through those torque and speed points, and you're going up hills, or you're going over calibrated hills, as I like to call them, to hit certain torques, you can look at your squiggly lines, which I have featured in the bottom here. You could look at your RMS values and say, all right, I want to look at IRMS and URMS and see how those things bounce around. We could look at digital meters. I want to look at every current, at 40 miles an hour, I want to hit 5 amps, 10 amps, 40 amps, 100 amps. At, voltage X, I want to hit currents 5, 10, 15, 20. At power X and Y, blah, blah, blah. So you can monitor these things this way and really know that you're hitting a wide variety of these points. Another thing we can do is if you can get to vehicle position, you can actually start to look at the ID and the IQ, so those control variables of the test. And one of my customers in particular really cares about what their competitors are doing for ID and IQ. So they go out, they find these hills, and they want to hit an IQ of X. And they can display that as a trace, or they can display it in an XY and start to look at things like angle and understand what the angle of their test is. Now, the cool thing is, no matter how you want to look at this, as you're going through those torque and speed points, as you're hitting different angles of hills at different speeds, you can trigger on any value. And you see a value you like, you can trigger. You see another value you like, you can trigger. And what we can do is we can actually plot a live heat map and populate those points live. So you can put any value on the X, any value on the Y, and any value in the heat area. And maybe, we want to look at sweeping ID or IQ, or we want to take torque and speed from a certain point. And we can trigger and populate that map live. And our drivers can start to see this and figure out, all right, what points am I hitting? Am I getting this curve in vehicle? And we can really start to have a nice feedback loop on doing these tests. I think that's a really cool way to visualize data, take in data, and really effectively use our vehicles as measurement tools.